Okay, this is a review of the free response for the Integrated 3 midterm. It will be broken into 3 parts. First part is just looking at solving equations and inequalities. The next part are going to be the free response questions that were not the performance task. And then finally the performance task will be the last video. So the first one, this is problem number 1. Solving equations and inequalities, and we're looking at 6x squared plus x equals 12. Well, anytime I have a quadratic or any kind of a power that's not just a linear equation, I've got to move everything to one side so I could try to use the zero product property of rule. So I need to have it equal to 0. So I'm going to subtract 12, and now I've got to factor this. Now, some of you feel comfortable with factoring, where you can just go and put out parentheses and then try to guess and check which way to go through it. If you're struggling with it, and this is a good example where this technique works really well, I'm going to take a generic rectangle. The 6x squared we see here go in this upper corner. The negative 12 we see here goes to the lower corner. Then, if I take these two numbers, and when I multiply those together, I get negative 72x squared. Well, the numbers that go here and here also have to multiply to give me negative 72x squared. But at the same time, they need to add to give me positive x. So don't think about the x's, think about the numbers. I want two numbers that multiply to give me negative 72, but add to give me 1. Well, the easiest combinations, well, two numbers that differ by it are 8 and 9. I want a positive, so that means I'm going to have the 8 as a negative and the 9 as a positive. So these are going to have an x in it. So I got 9x and negative 8x. Now these two will add now just to x, but they multiply to give me negative 72x squared. Okay, now to figure out the actual factors, what you can do is you can factor out going across. So 6x squared and 9x, I have an x in common, and I have 3 in common. Now I can figure out what number up here by saying 3x times what will give me 6x squared, or I can factor going up as well. 6x squared, negative 8x, they have 2 in common and an x in common. Either way, so you have a couple of options. To find most of them, it's easier to just think about multiplying. So 3x times 3 will give me 9x. 2x times negative 4 will give me negative 8x. And as a check, 3 times negative 4 equals negative 12. So now we've got our factors. Okay, so we're going to set each one of these equal to 0. So 3x minus 4 equals 0. 2x plus 3 equals 0. I'll add 4. Over here I'll subtract 3, divide by 3, divide by 2, and then those are my answers. So that's problem number 1. Okay, problem number 2. This is basically doing substitution. So the U is substitution. Mr. Reader likes to call it ugly substitutions. That's why I use the letter U. U is kind of traditional substitution letter that gets used in math. You can use any letter you want though. So since I see square root of 2x plus 1 in here more than once, that's kind of my clue that I should do a substitution. Then I can replace this with u plus 3 over u equals 4. I'm going to get rid of the fractions, so I'm going to multiply both sides or everything through by u. This gives me u squared, 3u over u is 3, and then 4u. Again, I got a quadratic. I got to move everything to one side, so it equals 0. This is an easy one to factor. I have two numbers that multiply to give me 3, but add to negative 4. Well, the only way to get 3 is 1 times 3. Since it's a negative right here, they're both negative. So u minus 3 and u minus 1. So when I solve it, I get u equals 3 and u equals 1. Now I'm not done here because I got to go back, plug in, and then solve. So 3 is equal to the square root of 2x plus 1. We're going to square both sides. Well, I got 3 equals 2x, square root of 2x plus 1, and I also get 1 equals square root of 2x plus 1. Square both sides. So I get 9 equals 2x plus 1. Subtract 1, I'll get 8. Then divide by 2, I get 4. Here, square both sides. I get 1 equals 2x plus 1. Subtract 1, I get 2x equals 0. So x equals 0. Okay, now I've got my solution. Third problem. This is basically using same base equations. So we've got to match the bases. Now, the ones you want to think about are bases of 2, 3, and 5. Those are the most common ones. There are other ones we could use, but these are the most common. So knowing your powers of 2 out to, say, like 2 to the 5th, powers of 3 out to maybe 3 to the 4th, and powers of 5 out to at least 5 cubed, maybe even 5 to the 4th, which is 625. So this is powers of 5. So I'm going to try to rewrite this all as powers of 5. So 125 is 5 cubed. Now you got to use your calculator on this part of the test. So if you get stuck, you could kind of guess and check a little bit and try to find those powers. So I got 1 over 5 cubed. This 125 is 5 squared, so it's because 5 to 2x. 1 over 5 cubed is the same as 5 to the negative 3. Now, with a radical, this becomes 5 raised to the 2x over 3. And when I raise to a power right here, I'm multiplying. This is like raising to the 1/3, so I have 1/3 times 2x, and then I'd get 2x over 3. Now, when I multiply, we add our exponents. So I get 5 raised to the negative 3 times 1 minus x plus 2x over 3 is equal to 5 to the first. Once I've got the same base and nothing else going on, so right now I've got more than one of those bases, get it down to such I could drop the bases and just solve what's left over. Set the exponents equal to each other. Okay, so I'm going to distribute. Get negative 3 plus 3x plus 2x over 3 equals 1. Don't want to deal with the fraction, so I'm going to multiply everything through by 3. So if I multiply everything through by 3, I get negative 9 plus 9x. We have 6x over 3 is going to be 2x, and then 3 times 1 is 3. Now it's a basic equation. So I get 11x is equal to 12. My answer is 12/11ths. Okay, last in the first set. So this is an inequality problem. So what is always a good idea when you have any kind of inequality problem that's not linear, just take this, treat it as if it was equals. So I'm going to subtract 17 first. Now for the absolute value, watch out, because sometimes we have special cases. If I got it equaling to a negative, I know that's a special case. I just go in, plug in any number I want to, usually 0 because it's the easiest one to figure out, and see if this is always true or never true. If it's always true, it's going to be all numbers. If it's never true, it's no solution. Okay, so for the absolute value, there's two ways to get 3 out of an absolute value. The inside equals 3, or the inside equals negative 3. Those are my two choices. Okay, so now I'm going to solve each of these. I'll add 3, get 2x equals 6, so x equals 3. Add 3 over here, I get 2x equals 0, so x equals 0. And now what I'm going to do is test these numbers on a number line. So I put out a number line. I'm going to plot the points 0 and 3. Now, since we had equals in the original equation, I'm going to use solid dots. Now I'm going to test the regions. The ones that are true is what my answer is finally going to work out to be. So I'm going to plug in 1 and see if it's true. Well, if I plug in 1, I'd have 17 plus absolute value of 2 minus 3. And that equals negative 1. But when I take the absolute value, I get positive 1. So I get 18 greater than or equal to 20. That's false. 18 is not bigger than 20. So I'll try a number like 4. Now this should go true, false, true. But we'll still play it safe and plug in numbers anyway. If I plug in 4, I get 17 plus 8 minus 3. That's 5. And I get 17 plus 5, that's 22. 22 is greater than 20, so that's true. If I try a number less than 0, -1 probably the easiest one to do. I'd have 17 plus -2 minus 3 is the absolute value of -5, greater than or equal to 20. Well, absolute value of -5 is 5 plus 17. That again is 22. That's true. So I'm going to shade the true parts. Now I'm going to write my answer. This part right here is shaded. Well, these are all values of x less than or equal to, because it's solid dot, 0. So when you write it in inequality format, you kind of use the inequality sign almost like an arrow to show which way it's going. Then for this part, I have x is greater than or equal to 3. Again, see how my arrow points in the same way this arrow goes. If my answer was between 0 and 3, we write that this way. 0 less than or equal to x less than or equal to 3. That represents my false area right here, but that's what my true area is. And we connect this with the word or. Some of you like to use interval notation. In interval notation, this goes from -infinity to 0, close bracket on the 0, and from 3, close bracket, out to positive infinity. Remember, you can never have equaling infinity, so you never want to have a closed bracket on those kinds of problems.